Chapter 6, Section 3, Naming Compounds and Writing Formulas. We're going to be working on naming and writing the formula for ionic compounds only. And the name is going to describe the ratio of the ions that are in that compound. And there are two types that we're going to look at, binary and polyatomic. Binary ionic compounds are any compound that's made from only two elements. So for example, Na plus Cl gives you sodium chloride. Common anions are your negatives, so these are going to be the ones that come at the second portion of the name, include fluorine, chlorine, bromine, iodine, oxygen, sulfur, nitrogen, and phosphorus. When you use anions in naming formulas, the end of the ion changes to IDE. Fluorine becomes fluoride. Chlorine, chloride. Bromine, bromide. Iodine becomes iodide. Oxygen becomes oxide. Sulfur, sulfide. Nitrogen, nitride. And phosphorus, phosphide. And we'll take a deeper look at naming when we review the material. Now, as far as naming your compounds and creating this chemical formula, there's a special way that we can remember how to do this. It's called the drop and swap method. So let's say, for example, that we have magnesium, which is Mg, and has an oxidation number of 2+, and we have chlorine, which is Cl, and has an oxidation number of 1-. Step 1 is to drop down the elements that we have. So Mg comes down, as does chlorine. All right, so we've got that far. Step 2, however, is to swap the oxidation number. So 2+ comes all the way over with Cl, and 1- comes over to Mg. We are swapping those numbers. And then the third step is to simply simplify those. So Mg1-, well, we know it's a negative, and because it's a 1, we can simply take that away. Because for example, in math class, if you have 1x, it's the same as just having the x there. Cl, however, has a 2. So we can take away the plus, but we need to make sure that we leave the 2. So your final example for your formula is MgCl2. Now, the first name, if we're talking about binary, is whatever that element is. So the first name is magnesium. The second name, however, needs to change. It needs to change into one of those binary common anions. So chlorine becomes chloride. Magnesium chloride is the name of this formula. Now we also have what's called polyatomic ions. Poly meaning more than one or many. So it's a covalently bonded group, and we're not going to break these down or anything, but you're going to be given groups of already bonded atoms, and it will already have a positive or a negative charge, and it acts as one unit. Now in this unit, you have to leave them together. So for example, these are common ones. Ones that we're going to really look at is ammonium. We'll look at hydroxide. We'll look at carbonate. We'll look at acetate specifically as well. But if you look at all of these, they have not only a charge to them, but they also have a number in the subscript for most of them. This number in the subscript has to stay with your element pieces. So NH4 has a +1 charge. Sulfate, SO4, has a 2- charge. So what you have here in this first part, you have to leave together. You cannot pull that apart. All right, so keep that in mind. That's very important. Now, because these polyatomic ions have specific names, we're not going to change the name. So when we go to name these, let's say, for example, if we had sodium and we combined it with hydroxide, it would simply be sodium hydroxide. Or if we took ammonium and combined it with chlorine, it would be ammonium chloride. All right, and we'll again look at that in review. So let's go ahead and look at an example for polyatomic compounds and combining those. So let's say that we have potassium, which is K, and is 1 plus in the oxidation number. And we have carbonate, which is CO3, and has a 2 minus oxidation number. So again, step 1, we're dropping down what we've been given. So the K comes down, and the entire thing, the CO3, has to come down. All right. So imagine, if you will, a set of parentheses around this. Step 2, and if you'll look, I've already added your parentheses there for you. Swap the oxidation numbers. So 1 plus comes from the K, goes over to CO3, and then 2 minus comes from the CO3 and moves over to the K. And just like before, we still have these pieces, but now we need to simplify. So to simplify these, you drop away your charges. The 2 minus becomes 2, so we have K2. And then our 1 plus, because it's already a 1, and we already have one sample of CO3 there, we just take that whole piece away. So that is your simplification step. Now a couple more things and we'll be done. Molecular compounds, that's the name and the formula, describes the type and number of atoms in that compound. We talked about that before earlier in chapter 6. So H2O, it tells you that you have 2 hydrogens. It tells you you have 1 oxygen. Right? It tells you that those 2 combined and give you water. NO2, nitrogen and 2 oxygens. All right, last section, section 4, structure of metals, and this is just a brief touch on this. Metallic bonding is between a metal cation and the shared electrons that it has around it with other elements. So usually with other metals. And when we get mixtures of 2 or more elements that are metals, we usually call them alloys. So we have copper, we could have steel alloys, etc. And that's it for chapter 6.